In question 1, we're given the curve C with equation y is x cubed over 4 minus x squared plus 17 over x, and we need to find dy dx, giving our answer in simplest form, where we need to start by writing y in index form, so it's x cubed over 4 minus x squared plus 17x to the minus 1, and then for dy dx, we know that we get the power down, deduct 1 from the power, so it's going to be 3x squared over 4 minus 2x minus 17x to the minus 2. Then in part B, we're given the point R with coordinates 2, 13 over 2 lying on C, and we need to find the equation of the tangent to C at this point, giving our answer in the form ax plus by plus c is 0, where a, b, and c are integers. I will start by evaluating dy dx at the point where x is 2. This will give me the gradient of the tangent. So we've got 3 times 2 squared over 4 minus 2 times 2 minus 17 times 2 to the minus 2. This gives an answer of minus 21 over 4. This is the gradient of the tangent. So we can recall that for a straight line with gradient m passing through the point x1, y1, the equation of this line is given by y minus y1 is mx minus x1, and therefore we've got that y minus 13 over 2 is equal to minus 21 over 4 times x minus 2. So we can start by multiplying throughout by 4. This will give us 4y minus 26 is minus 21 times x minus 2. We got rid of the denominators. We can now expand to get 4y minus 26 is minus 21x plus 42. And now I'll collect everything on the left hand side to get 21x plus 4y minus 68 is 0. This is the equation of the tangent in the required form. In question 2, we are given that the expansion of this triple bracket is ax cubed plus bx squared minus 32x minus 15, with a and b being constants that we need to determine. So we start off by expanding the triple bracket. It's x minus 5 times 2x plus 1 times x plus 3. I will start by expanding the last two brackets, so the x minus 5 stays there, and I have 2x squared plus 6x plus x plus 3. I will collect the like terms and then proceed in further expanding, so it's going to be x minus 5 times 2x squared plus 7x plus 3, and I will now expand further to get 2x cubed plus 7x squared plus 3x minus 10x squared minus 35x minus 15. Collecting like terms gives me 2x cubed minus 3x squared minus 32x minus 15, and therefore we conclude that a is 2 and b is negative 3. In part B, it says, hence find the integral of this, writing each term in its simplest form. So I'm going to use the expansion we have obtained in part A. We've got the integral of x minus 5 times 2x plus 1 times x plus 3 over 5 root x, which can be written as the integral of 2x cubed minus 3x squared minus 32x minus 15 over 5 root x dx. So I will write this in index form. So it's going to be the integral of 2 over 5 x to the 5 over 2, because I'm doing 3 minus the power of root x, which is a half. So 3 minus a half is 5 over 2, minus 3 over 5 x to the 3 over 2, minus 32 over 5 x to the half, minus 3x to the minus a half dx. So dividing by root x means I'm subtracting a half from the powers of x. So I got the integral here in index form, and I proceed in integrating, which means I increase the power by 1, divide by the new power. This is giving me 2 over 5 times x to the 7 over 2 over 7 over 2, minus 3 over 5 times x to the 5 over 2 over 5 over 2, minus 32 over 5 times x to the 3 over 2 over 3 over 2 minus 3x to the half over a half plus c. Do not forget the plus c. This is indefinite integration, so we'll always need to include the plus c. And we now need to simplify our answer. This gives me 4 over 35 x to the 7 over 2 minus 6 over 25 times x to the 5 over 2 minus 64 over 15x to the 3 over 2 minus 6x to the half plus c. In question 3, we've got the share price of a company being monitored. We've got the price exactly 3 years after the monitoring began, and then the price after 5 years. We are told that the share price capital V pounds can be modeled through this linear equation where t is the number of years after the monitoring began, and we need to find the value of P and the value of Q. We are just dealing with simultaneous equations here. We know that when t is 3, then V is 1.05, which means that if I substitute these values, I get that 1.05 is equal to 3P plus Q. And similarly, when t is 5, we have that V is 1.65, which means that 1.65 is equal to 5P plus Q. Now I could deduct the first equation from the second equation. So 1.65 minus 1.05 is 0.6 is equal to 2P, and the Q will cancel out. So we get that 0.3 is equal to P. And then I can take the value of P being 0.3 to be substituted in any of the two equations I have here. So I could go for the first one. This gives me 1.05 is equal to 3 times P, which is 0.3, plus Q. So 1.05 is equal to 0.9 plus Q, which means that Q is 0.15, and this completes part A. In part B, we are told that exactly capital T years after monitoring began, the share price was 250, and we need to find the value of capital T according to the model, giving our answer to 1 decimal place. So in other words, I will start with the model with the values of P and Q we found in part A. So we have that capital V is 0.3T plus 0.15. And we are told that when small t is capital T, then capital V is 2.50. So I will substitute this here. 2.50 is 0.3t plus 0.15. I will deduct the 0.15, leading to 2.35 is equal to 0.3t. And therefore, if I divide the 2.35 by the 0.3, that should be giving me the value of capital T. Remember, we need to give this to 1 decimal place. It works out to be 7.8. In question 4, we need to solve the given equation being equal to 0, showing detailed working. So we will start by writing down the equation. We've got x squared brackets 2x plus 1 minus 15x is equal to 0. So what we could do is expand everything. We get 2x cubed plus x squared minus 15x is 0. We start by observing that x is a common factor, so it will be taken out. X times 2x squared plus x minus 15 is 0, which can be further factorized into x 2x minus 5 times x plus 3 is 0. And therefore we have that either x is 0 or 2x minus 5 is 0 or x plus 3 is 0. And therefore x is 0 or x is 5 over 2 or x is minus 3. We have 3 solutions. We were dealing with a cubic, which can give us up to 3 solutions. In part B, it says, hence solve this equation here, giving you our answer in simplified third form. So we need to spot a connection between the part A and the part B. Any other method will score 0 marks because it's a hence. And it doesn't take long to notice that the x became y to the 2 over 3. Similarly here, x became y to the 2 over 3, and x squared is y to the 4 over 3. So we simply notice that the second equation in part B we're given is simply the first one with x being y to the 2 over 3. This means that y to the 2 over 3 is 0, or y to the 2 over 3 is 5 over 2, or y to the 2 over 3 is negative 3. Now, if y to the 2 over 3 is 0, this simply means that y is 0. And on the other hand, if y to the 2 over 3 is negative 3, is rejected. We cannot get any solutions here because y to the 2 over 3 must be positive. So I would say reject, since y to the 2 over 3 should be greater than 0. I could further explain this. We can take y to the 2 over 3 and think of this as y to the third and all squared. We know that something squared can never be negative, so y to the third all squared must be positive, and so it could never be negative 3. And we need to focus now on the middle solution. Y to the 2 over 3 is 5 over 2, which means that y is 5 over 2 to the power of 3 over 2. So we can think of this as y is 5 over 2 cubed and all raised to the power of a half. So this leads to y is 125 over 8 to the power of a half. Now, this is simply the square root of 125 over 8. Remember, we need to give our answer in a simplified third form, and we need to show all working to justify our answer. So the root of 125 can be thought of as the root of 25 times the root of 5, and the root of 8 is root of 4 times root of 2. So we've got that y is 5 root 5 over 2 root 2. We need to rationalize the denominator, so I will multiply top and bottom by root 2. This gives me in the numerator y is 5 root 10, and in the denominator it's 2 times 2, which is 4. So my final answer would be y is 5 root 10 over 4. And we also have got the other solution that y is 0, which should be rejected because we are told that y is greater than 0. So this is also rejected. I need to say reject, since y is greater than 0. And this agrees with the wording used in the question itself. It was asking for the answer. They are using the singular, so it was just one answer. So the only answer is that y is 5 root 10 over 4. In question 5, we're given the curve y is f of x. We have the derivative and the fact that we pass through the point P with coordinates 9, 8, and we need to find in its simplest form f of x. Well, we know that to find f of x, we need to take f dash of x and integrate it. So f of x should be the integral of 12 over root x plus x over 3 minus 4 with respect to x. So in order to proceed with integration, we need to write this in index form. So it's going to be the integral of 12x to the minus a half plus x over 3 minus 4 dx. Well, we know that in integration, we increase the power by 1, divide by the new power. So it's going to be 12 times x to the half over a half plus a third times x squared over 2 minus 4x plus c. We can then state that f of x should be 24 root x plus x squared over 6 minus 4x plus c. I still haven't used the fact that we passed through this point, and actually that's the point that I'll be using to find the constant of integration c. So we know that f of 9 is equal to 8, which means I can substitute to get 8 is 24 times root 9 plus 9 squared over 6 minus 4 times 9 plus c, which leads to 8 is 99 over 2 plus c, and therefore we've got that minus 83 over 2 is the value of c. So the only thing missing is just to state that f of x is 24 root x plus x squared over 6 minus 4x minus the 83 over 2. In part B, we are told that the line L is a normal to C at the point P, and we need to find the coordinates of the point at which this line L crosses the y-axis. I will start by evaluating f dash of 9. This will give me the gradient of the tangent to the curve at the point P. So f dash of 9 is 12 over root 9 plus 9 over 3 minus 4. This gives an answer of 3. This is the gradient of the tangent, and therefore the gradient of the normal can be found by flipping and changing the sign. It's going to be minus 1 over 3. Remember, the normal is perpendicular to the tangent, and I can now use the fact that for a straight line passing through the point with coordinates x1, y1 having gradient m, its equation is given by y minus y1 is mx minus x1. So y minus 8 is equal to minus a third bracket x minus 9. We are looking for the cross on the y-axis. So if we cross the y-axis, this means that x is 0. So I will be substituting x is 0 in the equation of the straight line, which leads to y minus 8 is minus a third bracket 0 minus 9. And therefore y minus 8 is equal to 3. Which leads to y being 11. We were asked to find the coordinates of the point, and therefore this point has coordinates 0, 11. In question 6, we are told that k is a positive constant between 0 and 4, and we need to sketch on separate axes these two curves. Well, I will start with the first one, which says that y is 2x minus k times x plus 4 to the power of 2. We recognize this as a cubic. If we expanded, the coefficient of x cubed will be positive, and therefore the shape will be something like this. We can also find the cuts on the axis. So if we put x to be 0, we get that y will be 0 minus k times 0 plus 4 squared, and this gives an answer of minus 16k. So we are cutting the y-axis on the negatives, and if we put y to be 0, we get that 2x minus k is 0, or that x plus 4 is 0, which means that x is k over 2, or x is negative 4, and we observe that the negative 4 is indeed a double root, and this gives us enough information to sketch the curve. So this should look something like this. We've got the cut, the double cut at the negative 4. We've got the other cut at k over 2, and we are cutting the y-axis at minus 16k. Now, for II, it's the graph of y is k over x squared. We know this is a reciprocal curve. We have the x squared in the denominator, so because x squared is never negative and k has been given to be positive, it means that y will always be positive. We've got asymptotes, the x-axis and the y-axis, and the graph should look something like this. Now in part B, it says state with the reason the number of roots of the equation 2x minus k times x plus 4 squared is equal to k over x squared. So obviously we are looking at the points of intersection between the two graphs. So it will make sense to put the two graphs together. So superimposing the two graphs, we can see that there is one point of intersection, which is over here on the right-hand side. And therefore, we can safely conclude that we've got one point of intersection, and therefore this means that the given equation should have only one real root, so hence one root. In question 7, we've got the curve with the equation y is f of x. We've got 4 points here, the coordinates are given, and using this figure, we need to find the range of values of x for which f of x is less than 6. Well, I could draw the horizontal line that passes through all these points, and you can see that this is lying on the horizontal line with the equation y is equal to 6. And therefore, we want f of x to be less than 6. We want to be below this straight line. So I can highlight the parts for which we are below this line, and we can easily see that it's anything before -4, anything between -1 and 2, and anything after 3. So our answer to part A could be that x is less than -4, or that x is between -1 and 2, or that x is greater than 3. We are looking at strict inequalities because we are solving a strict inequality here. In part B, it says state the largest solution of the equation f of 2x is equal to 6. Well, we can see that there are actually 4 solutions to f of x is 6, the -4, the -1, the 2, and the 3. So if we are solving f of 2x is equal to 6, then we can start by observing that the greatest solution is x is 3. So we observe that f of 3 is equal to 6, and because we are solving f of 2x is equal to 6, then we can set 2x to be equal to 3, and therefore we have that 2x is equal to 3 and x is 3 over 2. In part CI, we're asked to sketch the curve with the equation y is f of minus x. So we first need to appreciate what kind of transformation we're looking at. Essentially, all the x's get multiplied with -1, which corresponds to a reflection along the y-axis. So let's look at the original graph, that's the f of x, and we can start considering where each of the points P, Q, R, S will be mapped to. So P will go from -4, 6 to 4, 6. I have multiplied the x by -1. And similarly, Q will go to 1, 6. R will go to -2, 6. And S will go to -3, 6. So if I reflect the given curve along the y-axis, so this will be a line of symmetry, we expect to see something like this, with the points being here, and we've got that the point on the left hand side over here will be the -3, 6. The next one to the right of it, it's gonna be the -2, 6. Then we've got the 1, 6, and then the 4, 6, and we can see that we have reflected the original curve along the y-axis. So what we end up is the curve shown here in red. In II, it says, hence find the set of values of x for which f of minus x is greater than or equal to 6, and also that x is less than 0. So if I go to my graph here, I could draw the line of y is equal to 6. So this is the line y equals to 6. We want the f of negative x to be greater than or equal to 6. So we want to be above this horizontal line, and we also need to be in the negative x's. So the only part that's above the 6 and to the negative x is the part there. So I'm going to highlight the small part here, and we can easily conclude that we want the x to be between -3 and -2, and this is inclusive because we want f of negative x to be greater than or equal to 6. It's an inclusive inequality, so we include the two endpoints of -3 and -2. In question 8, we are given the plan U for a design for a pond, and we are asked in part A to find the exact area of the sector AOBX, which is the one we are highlighting here. So we start by noticing that the angle here is 2 pi over 3. We are obviously in radians. So the first thing we do is say that this angle here should be 2 pi minus the 2 pi over 3, which gives an answer of 4 pi over 3. So we've got the angle of the major sector BOAX. So to find the area of the sector, we start by reminding ourselves that the area of a sector is given by a half r squared theta, where r is the radius and theta is the angle of the sector measured in radians. In our case, the radius is 3, so it's a half times 3 squared. The angle theta is 4 pi over 3, so a half times 3 squared times 4 pi over 3 gives an answer of 6 pi squared meters. In II, we need to find the exact perimeter of the sector AOBX. So we need the 2 radii plus the length of the major arc here. So let's remind ourselves that the length of an arc is given by r theta, where theta is in radians. So in our case, the perimeter will simply be the 2 radii, so 3 plus 3, plus the length of the major arc, which will be 3 times 4 pi over 3, which is 6 plus 4 pi meters. Notice that the question is asking for the exact values for both the area and the perimeter. In B, we need to calculate the exact area of the triangle AOB, which is the one highlighted here. So we've got the two sides, it's 3 and 3. We've got the angle in between. So here I will be using the fact that the area of a triangle is given by a half AB sine C. So in our case, A and B are both equal to 3. So the area will be a half times 3 squared times the sine of the angle, which is 2 pi over 3. Remember that we need to put the calculator into radian mode, and we get an answer of 9 root 3 over 4 squared meters. In C, we need to show that the length AB is 3 root 3 meters. This is the length here. So I'll be using the cosine rule in triangle OAB because we know the two sides, the OB and the OA, and we've got the included angle 2 pi over 3. So the cosine rule says that the AB squared should be equal to 3 squared plus 3 squared minus 2 times 3 times 3 times the cosine of 2 pi over 3. Putting everything on the calculator gives that AB squared is equal to 27, and therefore AB is the square root of 27, which can be written as the root of 9 times the root of 3. So this is 3 root 3 meters as required. In D, we need to find the total surface area of the point, and we need to give our answer in square meters correct to two significant figures. So we need to essentially add up the area of the major sector, the area of the triangle, plus the area of this triangle here. We have already established that the length of AB here is 3 root 3. So the idea is for us to call angle BAC to be theta. We will use the sine rule to find theta, and based on that we'll find the angle here, and we can use this to proceed in finding the area of triangle ABC. So let's start with the sine rule. So the sine rule says that the sine of pi over 6 over the length of the side opposite the angle, which measures pi over 6 radians, which is 3 root 3, is equal to sine theta over 8. I can cross multiply to get 8 sine pi over 6 over 3 root 3 is equal to sine theta, and therefore this leads to 4 root 3 over 9 being sine theta. We can find theta by doing shift sine of 4 root 3 over 9, and this gives an answer of 0.8785 ... So I could actually go back to my diagram here. Angle theta is 0.8785 ... and I can find the angle ABC here to be pi minus the pi over 6 plus the 0.8785 ... Once we have the angle here, we can do a half AB sine of the angle to find the area of the triangle ABC, which will allow us to proceed in finding the total area. So we've got that angle ABC is pi minus the pi over 6 plus the 0.8785 ... This gives an answer of 1.7395. Notice that I use more accuracy in the intermediate answers. We are aiming for a final answer correct to 2SF. So here I'm using 5 significant figures. So this is done to avoid premature rounding errors. And therefore the total area will be the 6 pi, which was the area of the major sector we found at the beginning, plus 9 root 3 over 4, which was the area of the triangle, plus a half times 3 root 3 times 8 times the sine of 1.7395 dot dot dot. This is the area of the triangle ABC. Put everything on the calculator, you get 43.236 dot dot dot, which to two significant figures rounds to 43 square meters. In question 9, the first part, we are asked to write a half x squared minus 10x plus 22 in this form, where a, b, and c are constants to be found. So in other words, we are asked to complete the square. So we've got a half x squared minus 10x plus 22. I will start by forcing a factor of a half. So we've got a half brackets x squared minus 20x, and I leave the plus 22 on its own there. So I will complete the square on x squared minus 20x. So it's going to give me x minus 10 squared minus 10 squared, close the square brackets, plus 22. This leads to a half x minus 10 squared minus 100 and the plus 22, which can be further expanded into a half times x minus 10 squared minus 50 plus 22, which leads to a half times x minus 10 squared minus 28. So we can see that a is a half, b is negative 10, and c is negative 28. Alternatively, I could have used the method of equating coefficients. So let me explain this alternative approach. So what we do is that we set the two sides to be equal. So we've got a half x squared minus 10x plus 22. This is equal to a brackets x plus b all squared plus c. I will expand this to give me a brackets x squared plus 2bx plus b squared, close brackets, plus c, which can be further expanded to give me ax squared plus 2abx plus ab squared plus c. Now let's equate coefficients. Let's look at the coefficient of x squared. We've got a half x squared on the left hand side, and we've got ax squared on the right hand side. So it must be the case that a half is equal to a. Let's proceed to the coefficient of x. We've got minus 10x on the left, and we've got 2abx on the right. So this means that we have that negative 10 is equal to 2ab. Well, we have that a is a half, so minus 10 is 2 times a half times b, which means that minus 10 is equal to b. And finally, if we look at the constant term, the plus 22, this is equal to ab squared plus c. So we have that 22 is equal to ab squared plus c. We have already established that a is a half and b is negative 10. So I substitute this into the equation. We get that 22 is equal to 50 plus c, which leads to minus 28 being c. The only thing missing is to write the expression with the values of a, b, and c we just found. So we've got that a half x squared minus 10x plus 22 is equal to a half times x minus 10 squared minus 28. Now the point M is the minimum turning point of C as shown on the figure provided. We know that the equation of the curve was y is a half x squared minus 10x plus 22, which we have shown that it can be written in the form a half times x minus 10 squared minus 28. We are asked to deduce the coordinates of this minimum point, and we know that this minimum point is attained when the bracket becomes 0, so when x is 10, in which case y will be negative 28. So the point M will have coordinates 10, negative 28. You can think of this as negative 28 plus something which is always non-negative, so it's going to be from minus 28 upwards. So minus 28 is indeed the minimum, and this will be attained when the bracket here involving x is 0, so when x minus 10 is 0, which means that x is 10. In part C, we're given that the line L is the normal to C and it has equation y is k minus 1 over 8x, where k is a constant. We need to find the coordinates of P and the value of k. So we start with the equation of the normal, which was given to be y is k minus 1 over 8x. We can see that the coefficient of x is the gradient of the line, so the gradient of the normal is minus 1 over 8, which means that the gradient of the tangent can be found by flipping and changing the sign for the gradient of the normal. So this gives me that the gradient of the tangent is 8. So looking at the equation of the curve, it was y is a half x squared minus 10x plus 22. We can use differentiation to find an expression for the gradient of the curve. So dy dx is a half times 2x minus 10, which of course simplifies to x minus 10. And we are saying that there is a value of x that when substituted in here will give you a result of 8, which is the gradient of the tangent. So obviously we have that x must be 18. We've got the x coordinate of the point P, and I can proceed by substituting x is 18 into the expression for y to find the y coordinate of the point. So that's going to be a half times 18 squared minus 10 times 18 plus 22 gives an answer of 4. So point P has coordinates 18, 4. Now to proceed to find the value of k, I'm going to use the fact that the point P with coordinates 18, 4 lies on the equation of the normal. So I will substitute x is 18 and y is 4 into the given equation of the line L, which leads to 4 is k minus 1 over 8 times 18. This leads to 4 is equal to k minus 9 over 4. So we end up with k being 25 over 4. In part D, we're asked to identify the inequalities that define the region R, shown shaded here. So we have already seen that the equation of the curve is y is a half x squared minus 10x plus 22. The equation of the straight line is y is 25 over 4 minus 1 over 8x. We have already found the coordinates of point M to be 10, minus 28. And we can see that we certainly need to be below the straight line. So we need y to be less than or equal to 25 over 4 minus 1 over 8x. We want to be above the parabola. So we want y to be greater than or equal to a half x squared minus 10x plus 22. And we also want to be to the right of the vertical line here, which has equation x equals to 10 as it passes through the point M, which has its x coordinate being 10. So we want x to be greater than or equal to 10. These are the three inequalities that define the region R.